Welcome to the shop. In today's video, I'm going to be continuing work on the wood base for the glass, wood, and metal sculpture. I'm going to start off making the last of the machined parts, then I'm going to get into the wood shop and start making some of the strips that will be laminated together and pressed using the curve assembly fixture that I made in the last video. So let's get going. The part that I'm making today is simple as can be. I found a piece of aluminum scrap in my scrap pile. Got no CNC tool path. Just gonna cut it off real quick. This is a cold cutting carbide metal saw. I find that it works exceptionally well. Let me go over here and get a little bit of cutting lubricant. This works exceptionally well for cutting my aluminum and steel blanks that are later machined into shapes. I try whenever I can to make all of my projects out of aluminum extrusion rather than cutting things out of large pieces of plate. This is for a couple of reasons. First of all, my metal supplier doesn't really stock any plate. And second of all, cutting to length is fast and efficient, and it just gets the job done quicker. So a little WD-40 results in a fairly nice cut on aluminum. Once again, this is not a precision piece. Now, go over to the Scotch-Brite wheel, do a little very quick deburring. And then over to the Bridgeport. I'm not going to be using tool path, but I do like the DRO for what the precision is necessary on this part. I could probably just eyeball it or go with Sharpie marks, but it's so fast just to turn on the DRO, find zero with the Heimer. I mean, this is just so quick. It's just amazingly quick how I can get the zeros set up. Once again, love that power drawbar. Really makes really quick jobs like this go even quicker. So all I'm going to do here drill a hole, tap a hole, drill a couple of more holes, tap a couple of more holes, and then I'll be done. So I'm just going to go into the screen here and type in G0. I've got a coolant-proof and chip-proof industrial keyboard here, totally sealed rubber face. When I first set up the machine, I used a regular keyboard and was not surprised at all to discover that it filled up with chips. Just peck drilling here, try to control the chips. As I get close to the bottom of so many noisy things here. As I get closer to the bottom of the hole, I end up reducing the size of the pecks so that I don't end up getting the drill bit all clogged up with chips. Going to be power tapping here. Which is also very fast. And slow it down. Get the tap magic for aluminum cutting fluid, which so far out of all that I've tried seems to work the best of any of them. Got my hand on the reversing switch on the DRO so that I can reverse the tap as necessary. Power tapping works exceptionally well on the Bridgeport, and I've never had a problem. I haven't broken a tap. I haven't had any problems at all. Once again, power drawbar. Nothing beats the power drawbar. So now, I'm going to drill a couple of holes for 1032. I'm going to set the DRO. I don't need to go all the way full depth, and so I set 0 before starting drilling. These only need to be kind of roughly a ½ inch. Doesn't have to be accurate. And that's just how fast it goes. The way the shop is set up, the way the machines are set up, I can whip out quick, little simple metal parts in almost no time at all. And there it is. Not much of a part, but certainly will be useful in the next steps to come. So here's the fixture that I made last time. Next step is to go over to the lathe and do some very, very simple lathe work, and then go into the wood shop and make some wood parts, steam them, bend them, and see how it goes. So moving over to the metal lathe, I have some very, very simple operations that I need to do. Just gonna face off the end of a 3/8 hex bolt, drill a hole in the end, and then put turn down the end of a 3/8 threaded rod a little bit to make my clamping mechanism. I'm using a Bison collet chuck on the lathe, and the The wrench that comes with it is just painfully slow, so I have a workaround for that. I do like the collet chuck. Works really well for many things. This is a completely manual lathe. Does have DRO on all the axes, including the tailstock. The tailstock DRO is a custom thing that I made. At the moment, I don't have full CNC lathe capability. I have a CNC lathe attachment called the Rapid Turn that works with the Tormach, and it's adequate for the jobs that I need done. It's actually quite limited and quite minimal, but for the few things that I use it for, it's adequate. I thought long and hard about should I get a CNC lathe or a manual lathe, and unlike the Bridgeport, I wasn't able to find a combo CNC and manual that allowed full manual operation and full CNC operation. There were some, like the Track, that kind of almost came close, but their so-called manual mode was basically jogging a CNC machine, so you have no feel. It's, you know, the knob seems to feel effortless as you're turning as you're not paying attention and running the tool into the piece and breaking off the end of the tool because you got no tactile feedback. So I decided I really want a manual lathe. If the time ever comes when I really need CNC capability, full CNC capability, I'll get a real CNC lathe. I like to use stubby drill bits, the screw machine length drill bits, because for most applications, and of course what I'm doing here is totally non-precision work. If I was doing precision work, I would do everything properly with a spot drill, center drill, pilot drill, rough drill, and ream. For this, a stubby drill, no pilot hole, just shove it right in. I go very slow at the beginning, very slow, peck a little bit, do a little ship breaking. Just observe. And there we go. Quick and dirty. As I said in previous videos, I tend to match the degree of precision to the work being done. When quick and dirty is good enough, I do quick and dirty. When I need high precision, I slow down, take more care, and get high precision. So now, I'm going to be turning a bit of a shoulder onto the end of this threaded rod. And once again, this is totally quick and dirty, roughly touching off with the tip of the tool. Gonna preset. Preset the DRO. The DRO does read in diameter, so I don't have to do any arithmetic. So now, I'm going to find out what size I have. This does not need to be super precise, and hey, it's close enough. Close enough. Got all my quick change tools up on a rack up there. And there we have, okay, so here's the final result. It's a threaded rod that can rotate and center itself inside a screw with steel against steel contact. So as I thread the rod to produce a clamping action, I'm not running steel against aluminum in the previous parts. If this was going to be a fixture that would be used for many, many hours, well, I'd take the time and put in a nice bearing. But, you know, once again, quick and dirty, get the job done. Moving into the wood shop now, and I'm going to cut up some pieces of wood. I don't really have a complete plan of exactly what I'm doing, but this whole project has been a kind of an experiment, and so I'm going to continue experimenting. I'm going to cut up a variety of different hardwoods into small strips and put them all, steam them, and then put them all in the bending fixture and see which ones bend successfully and which ones crack. I'm going to be using a selection of wood that I happen to have in stock. I'm going to be using birch, rosewood, walnut, padauk, and a mystery wood that I found in my rack that I don't really remember what it was, but it's a kind of a cool wood. I want to be able to alternate between light and dark wood, and so I'm going to make up a bunch of test pieces and see how it goes. Go over to the chop saw. I'm just roughly cutting these pieces. Very nice feature that this DeWalt saw has, that it has a light that makes it really easy to see where the blade is going to hit on the wood. And once again, this is completely non-precision at the moment. As the job proceeds, things will get increasingly precise, but for this operation, just get them close. I have the wood saw arranged in a way that if I have a board that's too long, it goes right out the back door. And finally, choose the more appropriate end, even though I love the highly figured grain for some things. When I'm going to try to bend, I think I prefer the end with the more straight grain. Now I have the pieces so first step here, I'm going to kind of just roughly rip the wider ones to a more manageable size. I'm using what's called a glue line rip blade, and it produces a very smooth surface. Turn the dust collection on. Okay, I'm using a digital readout on the table saw. Pretty much all of my machines have digital readouts. I really like having more precision when I need it. And for this operation, I actually will be relying on the digital readout to help me cut my strips. So the first thing I'm going to do here is rip them down to the first dimension, which is going to be just slightly over, like 0.55, just slightly over a ½ an inch. And this will become apparent why it's necessary in the next upcoming steps. The final piece that I'm going to be making is going to be around a quarter, maybe 5/16, somewhere around 300 thousandths, but because of all of the processes that are going to be done and all of the manipulation and all of the machining, I kind of like to make the pieces a little oversized so that I have a little wiggle room for adjustment, and in case the edges get dinged up or in case there's something funny going on the outside extremes. So I apologize for the sound, but you know, woodworking is noisy. I have a remote control for the dust collector, but it doesn't work really well. Maybe someday I need to troubleshoot it. So what I'm going to be doing now, I'm going to be cutting some strips, and the final size of the strip is going to be 120 thousandths, just slightly smaller than 1/8 of an inch. I'm going to be cutting them to 130. Even with dust collection, hardwood dust is somewhat irritating. I'm going to be cutting them to 130 and then finishing them to the final size using the drum sander, and hopefully 120 is for the size of bend I'm doing. I believe it's going to be okay, but it may end up that that's going to be too thick, and we'll see. If the pieces crack, I'll have to change my design. So I'm going to start off here. There's two ways to cut small strips. You can set the fence to the small size and then run them through one after another without changing the fence. And it works, but I find that, especially with the digital readout, it makes more sense to start with the big end, kind of line up the edge, and then actually the correct method would be line up the edge of the blade as if I just finished a cut. Then the kerf of the blade is 90 thousandths measured with a caliper. And yes, I do use machinist measuring tools in woodworking, and try, when I need to do my woodworking within machine shop tolerance. So when you add together the two sizes, you end up with 0.22. So I'm gonna set my DRO to incremental mode and very carefully set 0.22 on the DRO, lower the blade a tiny bit, and proceed. That's reasonable. Probably I can't rely on all the pieces being the same dimension. I probably should rethink and size them all to reduce the amount of constant setting and resetting that I have to do. I'm using a push stick that has a kind of a long end on it, and this allows me to control the piece a little bit more than a traditional push stick with a shorter length. I also sometimes use two push sticks to try to control the far end. So now I should be able to run these a little bit more efficiently. Got a Cuisinart slow cooker that just happens to be the perfect size, and it has a steam setting. So here's the squeezing fixture, the bending fixture, and the way that it's going to work. I made off camera, I made a little sheet metal band to go around the part that I made earlier in the video. And then I've got a pair of nuts jammed together that I'll be driving with this electric tool. And that will force these pieces around that shape. Okay, so get some water. Over to the steam. I'm gonna steam it for a little over an hour. I know that the steaming rules are based on wood thickness, and this wood is not very thick, but still I'm somewhat concerned because I haven't steamed this particular type of wood before, about how many of these are going to bend nicely and how many are going to crack, and kind of doesn't hurt to give it a little extra. So, kind of arranging them to allow a little bit of airflow. And now we wait. So the pieces have been steaming now for a little over an hour, and it's time to take them out and see how they bend. So yes, plenty of steam. Steam looks happy, and this is the first time using this fixture. I have no idea how it's going to behave. And I'm going to try stacking up, I think 5 of these guys. So we put them in the fixture here. Get them in place. And then here we go. Will you look at that? I think we can call that success. Looks like everything worked right. The final assembly is going to be 7 pieces, but they're not all going to be bent together and glued together. It's going to be a rather complex process of bending, gluing, machining, bending, gluing, machining over and over and over again to make the internal pattern. And so that's pretty much all that there is to see right now in this video. The pieces are going to sit in the fixture for a while and just get used to their new shape and dry out a little bit. Then after a couple of days of drying, this is going to be a long process. It's going to take several days of bending, drying, gluing, bending, drying, gluing over and over and over again. And in between, there's going to be a bunch of machining when this fixture goes back into the milling machine. But, you know, we'll see how it comes out. This could be a very interesting experiment. So far, so good. The bend looks good. I think it's going to be a success, but everything about this project is highly experimental. So thank you for watching. It's been fun.